In this section, we are going to be conducting a case study and we are going to be making use of various things that we have learned in this course, throughout this course. So we are going to be making use of the AdventureWorks database. So this is the online transactions of a fictional multinational company called AdventureWorks. So these are transactions that have gone over the period of some years. So we are going to be analyzing this particular database. So for you to be able to get this AdventureWorks database, so I need you to install the remote package. So I'm going to use the install packages to install the remote package. So after doing that, then I'm now going to install and load the AdventureWorks database. So the AdventureWorks database is also a package on its own. That is why you need the remote package. So I'm going to say remote, then install GitHub. So when doing this process, please ensure that you are connected to the internet. Adejumo, Ridwan, then / then AdventureWorks. So this is how you can install the AdventureWorks database if you want to make use of it. Ensure you have already installed remotes. I already have it installed. The remotes with these two columns you are looking at is just the same thing as loading the remotes. But because you are using the remotes package only once, that is why we are using this form. So instead of writing it like this, I can just say library remotes. So if I just load this library remotes, then I can use the function install GitHub. But because I'm using it only once, I don't load the entire package. Then I'm just going to say remotes because I'm just interested in using the function. And after that, I'm done. So I'm going to say remotes install GitHub. So this is where it is saved on my GitHub. So Adejimo, then AdventureWorks. So once after doing that, when you run it, it's going to install the AdventureWorks database for you. So I already have it installed on my system. That's why I'm seeing this warning. Then next is for you to now load the AdventureWorks database. You're going to say library, AdventureWorks. So you load the database. So the database has already been loaded. In the AdventureWorks, we have 6 data sets. First is the sales. This is the main data set that we're dealing with. So this is the sales data set. This contains details of transactions, 60,398 transactions that have happened in the period of some years in the AdventureWorks. So people have already bought stuffs online from this company. So these are the transactions. You can see we have order date. We also have order date key. So this is a relational database. So these keys that you are looking at are connecting this particular data set, the sales data set, to other data sets. So this product key connects this data set to the product data set. So let's view the products data sets. So if you want to find information about a particular product, use this product key, which is also available in the sales data set. While the customer key connects us to the customer data set. So let's view that too. Also, we're going to be working with them. Since this is a database, customers. So you can see that we also have the customers data set. This is the customer key. It connects it to the sales data set. So now let's have a critical look at the sales. So you can see we have sales order date. I told that this is the date an item was ordered. Then of the order date key, which is also just like the date, except that in this situation, the slash was removed just to give it a unique ID. We have the product key, customer key, sales territory key. Then we have sales order number, ship dates, sales order line number, order quantity. They also have unit price of an item. Then we have extended amount of an item. These are almost the same, the unit price and the extended amount. You can use any of them interchangeably. They are both the same. They are both containing the same values. So extended amount and unit price. Then we have unit price discount amounts. We have the product standard cost. This is the cost price of an item. So this is the actual cost price of an item. Why this is the amount the item was sold. So this is how much an item was bought by the company, and this is how much this particular item was sold. So for example, now let's just look at this. This item was bought for approximately $413, and it was sold for approximately $700. So you can know that the gain now on this is over $200. This is the particular gain on this particular item, and this is total product cost, which is also the same thing as the product standard cost. We have sales amount, also the same thing as the extended amount. Then we also have tax amount, the amount of tax that is on an item. Then we also have freights. So this is like the transportation of an item. Then we also have region month ID. We also have the region's month ID. So we go to the customers also. We have the customer key, geography key, the name of a particular customer, the birth date of a particular customer, the marital status. We also have the gender. You can see we also only have 2. values married or single. We also have gender, male and female. Then we have the yearly income of that particular customer, the number of children the customer have, the occupation of that customer. Then we have house owner flag, if the person owns an house or not. We also have the number of cars owned by that particular customer. Then we have the address line. We also have address to that second home address if it exists for a particular customer. Then we also go to the products. We have the product key, the product subcategory key, the product name, the standard cost of that particular product. We have the color of that particular product. We have the safety stock level. We have the list price. We have the size of that product, the size range, the weight of the product, the days to manufacture, the product line, the dealer price. This is the dealer price and the class, then the model name. So this is just like the name of the product. We have the description also of the product. So this is just all about these 3 data sets that we are going to be working with. And the last thing we are going to be doing, which is just like our tools, without this we can't perform any analysis, is to load the tidyverse. So it's just going to load everything that we need to use. It's going to load all the packages that we need to perform this analysis. So the first question we are going to be answering, we want to know the total sales that was made in each product subcategory. So you can see this is our products data which we have here, but we don't have how much this product was sold, but this is available in the sales data. So now that means we need to combine these two together so that we can know the total sales that was made in a particular product subcategory, and which is why we have the product ID. So you can see the product key. So that is why we have the product key. So this product key is going to be linked to the product key in the product data set. So by when we link it, then we can now know, okay, for this particular subcategory, this was the total sales that was made. So which function are we going to use now? Then I guess you guessed right, you are going to be using the inner join. So it's going to join these 2 tables together because we need the subcategory. Because the subcategory currently now is not present in the sales table as you are looking at it. Subcategory is not present, and in the products, the subcategory is present. While in the products, the subcategory is present, but we don't have in the products how much these items were sold. This information is available in the sales. So we need to now join these 2 particular tables to be able to now get the information we're interested in. So the first table is the sales. So the first is the sales, then the second table is the products. Then we are joining it by product key. So when you run this now, you can see we have 39 columns, which means that those columns have already been joined together. But that doesn't stop there. We are interested in knowing the total sales that was made in each product subcategory. So I'm now going to pass this to the group by function. Pass it to the group by function. So I'm going to group by category first, because we have category and also have subcategory. We're going to group by category first, then subcategory. So, and I told you that the group by function can't work alone. We're going to summarize. We are interested in knowing the total sales that was made. I'm going to say summarize, create a new column called total sales. And this total sales is going to be the sum of the sales amounts. So how much those particular item was sold is going to be the sum of that particular sales amount. So then when we now run this now, so you can now see that we have a new column called total sales, and we also have a product subcategory. But now if you look at it, we can't know in which particular subcategory was an item. We have to be using our eyes to scan, or we have to be going to the next tables to now know in which particular item or sales made the most, or which particular item has the least sales. So for us to be able to know this, we are going to now pass it to our arrange function. We want to say arrange in descending order, so from the highest sales to the lowest sales. So descending order, total sales. So we now run this, we can now see that much sales was made under the bikes category. So people bought road bikes most, then mountain bikes, then touring bikes. So people are more interested in road bikes, then mountain bikes, then also touring bikes. And also under accessories, we have tires and tubes and elements. They made blood sales. So these bikes is possible that because bikes are expensive than all these that are accessories and clothing. So that is why the total sales was much more in the bikes than if you look at it in other categories. So now what if we are now interested in the categories instead of the subcategory? So I'm just going to remove this subcategory and just run it. You can now see we only have for the bikes, accessories, and clothing. Now, because this is a sales data, we don't need decimal, we just need it rounded. So I'm going to be using the round function. I'm going to use the round function. to round it to the nearest whole number. So by adding the round function now, you can now see that I have bikes as the most sales was made in bikes, then accessories, then clothing. And this can be understandable because bikes are more expensive than accessories and clothing. So we have over 28 million was made from bikes, then we have 700,000 plus was made in accessories. That is total sales that was made. Then clothing, we have what, 339,000 plus that was made under clothing. So this is a particular question we've already answered to know the total sales in each product subcategory and also the total sales in a product category. So in the last lecture, we calculated the total sales that was made in each product category. Now we are now interested in the profit margin that was made in those particular categories. So now we're interested in the profits that this particular organization has made. We know the total sales, but we know that those items come at a cost price. So now when we subtract that cost price from the amount that item was sold, then we now have the profit that this company actually made. So this will let the company know if they have made a profit or they are on a loss. So now I want to know these particular profits for each product category. So now I'm going to go and copy the inner join. I'm going to copy it since I'm going to be making use of it and paste it here. So I'm now going to pass this joined table. I'm going to pass it to the mutate function. I'm creating a new column called profit margin. So profit margin is the selling price minus cost price divided by the selling price times 100. So that is just the profit margin. So I want to know the profit margin. So I'm going to say profit margin is equals to, I'm going to put it on a new line. So it's going to be equals to sales amount. Sales amount. So this is how much the item was sold minus product standard cost. So this is the amount of making a particular item or a particular product. So this is sales amount minus product standard cost. So if I go to run this like this, we're going to get a new column called profits, not profit margin, because this is just the sales amount minus product standard cost. But we're interested in the profit margin. Profit margin is going to be sales amount minus product standard cost divided by the total sum of all the sales that was made. So the total sum of all the sales that was made, sum sales amount, then we now multiply it by 100. So when you run this now, we're going to have a new column. When you go to the extreme end, so you can see we have a new column called profit margin. So you can see the profit margin of each particular product. Now, we're interested in the profit margin for each particular category. So we're going to pass this to the group by function. So first of all, we group by category. Then let's also see for subcategory. So when we do that now, we're now going to pass this to the summarize. Because it's already grouped by category and subcategory. Now summarize is now going to add all those profit margin together, total profit margin. So total profit margin is going to be equal to sum of the profit margin. So when you run this now, you can now see we have the total profit margin. But let's make this in descending order so that we can know the highest, the subcategories where the highest profit margin was made, then to the lowest category, to the category where the lowest profit margin was made. If I pass this to the arrange, so the arrange is going to be in descending order of total profit margin. So you can now see that the highest profit margin was made from road bikes, then mountain bikes, then touring bikes. And also we have tire and tubes. Profit margin was made from here. The highest profit margin was also made. The highest profit margin in accessories is under the subcategory tires and tubes, then helmets. So this allows us to know that, okay, the more profit was made from road bikes, the more profit was made from mountain bikes also compared to touring bikes. So with this, we can be able to know that, okay, this is our profit margin. But most of the time, it's also good to represent your table in a visualization format, because they say a picture speaks 1,000 words. So I'm going to pass this to the ggplot function, and I'm going to say mapping is equals to aesthetics, where our x value is going to be equals to total profit margin, and the y value is going to be equals to So y is going to be equal to subcategory. Then we now use the plus sign. Remember, now the pipe operator to the geom column function. And use the geom column function to also plot your bar plot. I'm going to pass it to the geom column function. So you can see that by giving x as the total profit margin, it is going to make the x value to be the profit margin instead of the y, because I want it to be in a horizontal plot, not a vertical plot. So that's why I'm going to give the value of x as total profit margin and the value of y as subcategory. So now you can now see that when we pass it to geom column function, we have this plot as you are seeing here, which now shows the subcategories where the highest profit margin was gained. So let's apply some colors to it. We are now going to say fill. If I say fill, it's going to be subcategory. It is going to fill the graph by subcategory. You can see that by giving my fill is equal to subcategory, you can see that these columns in my plot have been filled by subcategory. As you can look at it here, they have been filled by the subcategory. Now, it's a good thing in visualization, you also give your plots in a descending order. So these bars should be descending, that is from the longest bar to the shortest bar. So this is where this reorder function comes. So I'm going to remove this subcategory here and use the reorder function. So the reorder is going to reorder this bar from in descending order from the highest profit margin to the lowest profit margin. And now say subcategory, then it is now going to be in descending order by the total profit margin. So you can see it. So when I run this now, you can now see that my bar is from the longest bar to the lowest bar. So this is much more better than giving a scattered bar plot. So now I want to group this by category instead of subcategory. So I'm going to remove this field is equal to subcategory and say field is going to be equal to category. So that I'll be able to know that, okay, for these particular bars, when I see these particular bars having similar colors, I will know that they belong to the same category. So when I run this now, I can now see that now I have just only 3 categories. So and any bars sharing the same colors, they all belong to the same category. So we still have some little works to do on our bar plot. We don't have the proper labeling. So I'm going to give a proper labeling. So I'm going to pass this to the labs function, which is going to give us a proper labeling for our x, y, and also the title. So I'm going to say the x should be profit margin. Then the y is now going to be equals to product, subcategory, and the title is now going to be equals to profit margin for each product subcategory. So by doing this now, I'm going to have the proper labeling for our bar plot. So you can see our bar plot with the proper labelings, the product subcategory, and also the profit margin. And you can now see the bars are in descending order for each product category. So any bars sharing the same color, they actually belong to the same subcategory. So with this now, we can use a visualization to now show someone that, okay, these are actually the subcategories which are making more profit compared to other subcategories. So the next question now I'm going to be answering is the profit margin of sales over time. So we want to know, because we already have a date which is showing us the day a particular item was ordered. So we want to know the profit margin sales over time. So have the company or the organization been making profits over the years, or they have actually been going down over the years? Now in the section of data visualization with ggplot, where I explain to you about time plots or line graphs. So this allows you to see something over time. So I want to now see this profit margin over time, how this profit has been changing over time. Has it been increasing, or has it been decreasing, or has it been stagnant for a while, or has it dropped at a particular time? So all this information you can answer using our line graph. So I'm going to pass the sales data to be passed to the mutate function. So let me just go back to this our previous code and copy this mutate. So once I copy it, I'm just going to paste it here. So this is just our profit margin. We don't need to be repeating it. So now, but another thing, interesting thing is that if you now look at our sales data, so let me just have a little view head of our sales. So you can see that this data, this order date is not actually a date format, it's a character format. And we need a date format for us to be able to visualize our profit margin over time. So I have to convert this order date to a date format. So this is where I'm now going to use I'm going to create a new variable called order date. So this is going to overwrite the previous one, which is equals to, I'm now going to use a package called lubricate. And inside this package, there is a function called DMY, which actually converts your data set to dates, months, and year. So DMY, dates, you can see dates, months, and year. So if you can see our data here, we're having date first, then the month, then also the year. So this will now convert it to date, month, and year. It's going to convert it to a date format. I'm now going to say the name of our column is order dates. So let me clear this. So when I run this now, you can now see that it has already converted that column to a date format. This to the group by function. We are going to be grouping by order dates because we are interested in knowing our order, the profit margin that was made over time. So by passing this to the group by function, we need to summarize it. You can see that in a particular day, we can have like 5 orders. You can see on the 1st of July 2016, we had like 5 orders. So the company had like 5 orders in this particular. That is why we need to group the order date and also summarize it by getting the sum of the profit margin in each particular date. So I'm now going to say summarize profit margin. So profit margin is now going to be equals to the sum of the profit margin. So you can now say for each order date, we have the total profit margin that was made in that particular date. You can see for the 1st of July 2016, you can also see for the 2nd of July 2016, for the 3rd of July 2016, and so on. So we have 1,122, 1,123 days. So we're going to be visualizing these 1,123 days and this profit margin. We are going to use a line graph to visualize this. So we're now going to pass this to the ggplot function, our mapping, which is equal to aesthetics, and our x-axis. We know that our x-axis is the dates, which is order dates. So this is our axis profit margin. We are going to now pass this to the geom line function to create our line plots. So this is now our line graph. So this is now the line graph that we are having. Now take a critical look at this line graph. You can see that our profit margin, we have 0.15. That is on a day, a particular day, the highest profit margin was 0.15. But if you now look at it, there's a particular day where profit margin drastically dropped. From around a profit margin of above 0.1, it dropped close to 0.00. So what now happened in this day? We will need to find out what happened in this particular date. And this was in the year 2019 that sales dropped drastically in a particular month. In a particular month in 2019, they had the highest profit margin. So let us investigate what actually happened in this particular month, or in the year 2019, what actually happened that sales dropped this drastically. It dropped from above 0.1 to almost close to 0.00. So let's know why sales actually dropped that much. So what happened in 2019 that profits actually dropped from a very high profit margin to a low profit margin? So what actually happened is what we're going to be investigating in this particular lecture. So let's go back to this line plot and copy this. I'm going to copy this and paste it. So I'm going to pass this to the filter function and filter for the year 2019. So I'm going to say order date. Order date is greater than or equals to. We're interested now only in the year 2019. I want to plot a line graph for that particular year, 2019. So I'm going to say 2019. So order date is going to filter for any date that is greater than or equals to the year, to the 1st of January 2019. So it is going to filter for us any date that is greater than or equals to the 1st of January 2019. This filter now is going to filter for us other dates that is greater than or equals to the 1st of January 2019. So we are going to pass this now to the ggplot function. I'm going to say aesthetics, x is equals to order dates, then y is equals to profit margin. So now we are plotting a line graph for just the year 2019. Then geom line. You can now see that in the month of July, you can see that sales dropped in the month of July drastically. So that means the drop in the profit margin was actually in the month of July. So now we are going to focus on the month of July. and try and look into the profit margin of this particular month, of categories in this particular month. So we are going to know why sales actually dropped in this month of July. I'm going to say inner join. I'm going to be joining my sales with my products. And I'm going to be joining it by the product key. And I'm now going to pass this to the mutate function, which calculated profit margin for us. So let me just go and copy it. So this was the profit margin. I'm just going to copy this and paste it here. So we already have our profit margin. We have the order date, which we converted this order date to a date format. We also have to give that column. And we're now going to pass this to filter. So on the dates for the month of July, we are going to be checking for the 1st of July. So we're going to be checking for sales that were made on that particular 1st of July upwards. So that would be greater than or equals to 2019. So I'm filtering for dates that are either July 1st or July 1st upwards. So I'm going to be filtering for dates July 1st upwards. 07 July. Then we're now going to be grouping by. So we want to see the category. We want to see the profit margin of these categories in the month of July. Then we're now going to summarize by profit margin, which is equal to sum profits of profit margin. We're going to sum the profit margin for all the items under a similar category to now get this profit. So sorry, I gave group instead of group by. It's supposed to be group by. So this is now going to get us the summarized profit margin of items that were sold, or let's say categories of items in the particular month of July upwards, July 2019 upwards. So when we run this, you can now see we have only 2 categories. So that means in the month of July upwards, only 2 categories of items were sold: accessories and clothing. So this is a reason why the sales or the profit margin actually dropped in that particular month. No items related to bike were sold, because we know that most of their sales from that organizations were made from bikes, and also most of the highest profit margins are in bike items. This is the reason why in that particular month of July, sales actually dropped, because after month of July, they were only selling items belonging to 2 categories: accessories and clothing. And we know that items belonging to accessories and clothing are not as expensive as items that are belonging to the bikes category. So this explains the reason why for the drastic sales drop that particular month of July in the year 2019. If we also go back to take a look at the time graph of the year 2019, in fact the peak of sales was made in that particular year. And we will not be surprised if we found out that it was items related to bike that made this points to actually rise to this extent, where the profit margin is even higher than 0.15 in that particular year of 2019. The next question I'm going to be answering now is the customers where most profits were made from. So I want to know the customers that actually, so these are customers that actually spend more in this particular company. They actually buy products more, or buy more expensive products more. We want to know them in this particular company. So if we go back to our customers data, you can see that we have customers name. We also have where we have occupation of customers. We want to know the kind of occupations of these customers, and also want to know the type of these particular customers. We have the gender and the marital status, the details of these customers that actually patronize this company more. So I'm going to pass the inner join function to, I'm going to use the inner join function to join the sales and the customers. So I'm going to be joining by the customer key. So I'm going to pass this to the mutate function. So though I don't need to write this again, let me just go to our the previous ones we have done before, and just copy the mutate function. I'm just going to copy paste it here, put a bracket at the end. I'm now going to pass this the group by. I'm going to be grouping our customers by occupation. After grouping by occupation, then we group by marital status. Then we now group by their gender. Then after grouping, we summarize the total profits. So you can use profit, you can use sales, anyone. Let's just know the total profits, sum, profit margin. I'm now going to pass this to the arrange, because we want it to be in descending order. So descending of total profits. When we now run this, So you can see that we have 5 occupations: professional, skilled manual, management, clerical, and also have manual. So, and you can see that out of this occupation, the professionals are the ones that are even making more profits for the organization. And these professionals, it is the single females. So the highest profit margin are made from single females. So these are like the ones patronizing the organization more. Then we also have professional married males, then we also have professional married females. So this allows us to know that, okay, which particular occupation can the organization target, or where can they usually divert more of their adverts to. If the organization knows that professional single females are the ones where they are making more profits from, you can usually target their adverts to this specific group of people. In fact, they can target most of their adverts to professional, so they will know that, okay, these are people that are even interested in our items. Or you can see that when you now go to the manual, you see that the profit margin is not that much. So not much profit margin is made from clients with manual occupation. So the company can know where they can spend their resources in terms of advertisements and other things.